Hello and welcome to That Maker Show, where we break down the barriers to entry to the maker movement. I'm here with my co-host Craig, and today we're going to talk about 3D printing.
And I am so excited to talk about 3D printing because you know so much about this and you're always doing stuff and I know nothing about it. So what is 3D printing?
3D printing, well, most of you will be familiar with 2D printing, where you get a piece of paper, you put it in a printer, and what happens is ink is deposited in 2 dimensions, the X and Y.
Right.
And it comes out the other end and it looks great. 3D printing works on a very similar principle, but instead of ink, it uses molten plastic, so that's hot plastic.
Whoa.
And it goes on the X and Y axis, but then it goes on the Z axis, and it prints that molten lava layer by layer until you've got a 3D object.
So these are 3D printers here?
Yes.
These are these devices that are printing up?
Yeah, this one is a single plastic extruder, so it only prints in one color.
What's an extruder?
Oh, good question. I'm glad you're here.
Yeah.
You see this at the bottom here?
Right. Yep.
That heats up to about 200 degrees Celsius, and it melts the plastic and extrudes, and it pushes out the plastic onto the bed, and it moves around like that, and then up and down.
Oh, cool.
So this one also moves left and right and up and down, and it prints in 3D, but this prints with 2 different colors, or it could print in 2 different types of material as
There's different colors of this stuff.
So if you go down there
This?
and pick up these things,
Oh, okay.
So this is the equivalent of ink for a 3D printer.
Gotcha.
It's
What's it
called
called?
filament, 3D filament.
Okay.
And it comes in a variety of plastics. The 2 main plastics you're going to get is ABS, which is like Lego. The plastic you get in Lego is very rigid and strong.
Okay.
And then you can get PLA, which is made of corn, which is biodegradable.
Okay.
It'll degrade a lot quicker than this would. So it's a byproduct of corn.
Oh, that's cool. So like recycling.
So it's recycling, yeah. So you can get these colors. This particular one is transparent, and so you can have some really cool effects with that, which I'll show you.
So 200 degrees, does it make smoke? It's like a...
So yeah, that's a good question.
Thanks.
It creates particulates in the atmosphere. These things should only be used in a well-ventilated area, probably where people aren't hanging about. So you could have it in your garage or your basement or somewhere away from people, because it's not advisable to inhale this stuff when it's at 200 degrees Celsius. But the more the airflow, the better, really, for humans. But this model is closed here because with certain filaments like this ABS, as you get bigger and bigger and bigger, it can warp as you're printing. So if you enclose it and keep the heat inside, it will produce better prints. Whereas like with smaller printers like this, you don't get the warping issue because you just only print in a smaller object.
Sure.
So shall we take a look at some
Yeah,
things?
please. What are people using this for?
Okay, so I'm using it for lots of different reasons.
Yeah.
Some people make toys for the kids and things like that. I've made a few things, but I'll make toys for myself. So this is from the video game. This is from the video game Destiny, which there's a character called a ghost, and this is the ghost, and it lights up inside.
That is so cool.
So it's got a tea light inside, and
So you made this?
yeah, I 3D printed this, but I didn't design it. I acquired the design off a site called Thingiverse. Thingiverse is a website that has 3D designs that you can just download and print out.
Oh.
So, like, I'm a Doctor Who fan, so I've
so
got
cool.
a TARDIS.
So cool.
And for people who like Star Wars, there's Darth Vader Buddha there.
Very cool. It's like smooth too. It's not sharp edges.
Yeah, so depending on the printer, it can it has fine grain movement, so it's very, you can get different finishes. But if you notice, I don't think you can see it on the camera, there are ridges to it, and that's each layer of the 3D print as it gets deposited. So you're limited on that axis by the layers. There are processes that you can do to make it smoother, like on that plane as well. And because it's made of ABS plastic, you can melt with acetone. Another pro tip for that is do not do that in a non-well ventilated area. You've got to make sure that it's well ventilated, because acetone will kill you if you inhale too much. So you put this in a bath of either acetone vapor or cold acetone, and it will make this all shiny and smooth, like a finished piece that you would maybe buy in a store or something like that.
It's gorgeous. This is awesome. And you found this too on Thingiverse?
On Thingiverse.
Wow, this is cool. So are they all just kind of like ornaments and stuff on there? Is there other stuff?
Yeah, there's other stuff. There's more practical uses. We had a load of toothbrushes just hanging out on the side of the sink, and I thought, I need a toothbrush holder. Oh, Thingiverse, there probably will be a toothbrush holder on Thingiverse, and there was. So I printed it like this, and then you just pop it on like that and stick your toothbrushes in. So
that's so cool.
There's things like that. And also for the 3D printer itself. So because these printers are open source by design, that means you can improve them and share the designs that you've improved back with the community. I've actually modified this from what it came as. So over here, there's a door holder, and here for cable management, you can hold these so they don't pull so much on the filament when you're printing. But say, for example, when you need to get a print off the bed, like this little dude here, it's stuck to the bed because of the high temperature. It's practically bonded to the surface of the printer. So you need to take a wallpaper scraper like this and chisel it off. And imagine sat here and this keep falling on your head all the time.
Yeah.
So I looked on Thingiverse and I found this door holder, so I can get in and chisel at it and then pop him off like that.
And it fits perfectly because the size is.
Yeah.
Oh, that's awesome. Oh, so it's like fixing itself.
Yeah, exactly. So even if you are the first person to find a problem out, you can fix it yourself. And in fact, I did that. So right on the back of here, the 3D printing ink, or the filament, is on a spool.
Right, one of these guys, right?
Yeah. So this is the one that came with my printer. And as you can see, the spool holder there clicks in really nicely with that spool. However, if you pick up another one of those, this has got a smaller hole and
doesn't fit.
So I've got a problem here, but I can fix that problem. So I went onto Thingiverse and I searched for the manufacturer name for this filament, and I found a design like this for a different type of printer, just slightly different from mine. And then I modified it so it would fit perfectly with these other spools. And
That's awesome.
Shared this again on Thingiverse, and other people have downloaded it and printed it and actually taken pictures, really high professional pictures of this item here, because it was able to serve the purpose.
Cool. So that hardware is open source. I would imagine, are there tools for things that are not open source?
Sure. So I went to IKEA to buy these boxes, and this is not the best design.
Sure.
But on Thingiverse, again, I searched for IKEA, and they just so happen to have these little clips that you can print out,
That's incredible.
put on your boxes, and it doesn't come off anymore.
Wow.
That's cool, isn't it? So yeah, I've printed 16 of these out.
Did you give it a Swedish name? We can cut that.
Yeah. I don't know any Swedish, so I mean, if I did, I don't know.
Are people printing other things like that?
So yeah, people, say for example myself, I'm a person. I'm creating this internet-enabled Tamagotchi. So back in the 90s, there was these little virtual pets.
Right.
So this would have the face of the Tamagotchi on, and then I was trying to build an enclosure for it, because obviously you don't want this dangling out everywhere.
Right.
And you see, it's a bit too tight. So within minutes, I'd 3D printed a modified design here.
Wait, how do you do the design?
Yeah, there's 3D modeling software that you can use. So you just use basic components like cubes, cylinders, and you can measure the corners of things and do things like that. So use this 3D software in order to generate these cases that eventually I'll get around to finishing to put this Tamagotchi inside. So for tinkerers, they can create cases. So here's some examples of cases that people build. So someone's made a Game Boy. So you can put a computer inside, a small computer like one of these Raspberry Pis. You can put them inside of these things and make a games console. Or because these tiny computers come without a case, you can just make the cases to protect it.
Awesome.
From the environment. So yeah, people are making cases for all sorts of things.
So when you were building those things, how did you start doing the models? How did you know the right sizes? Like, did you have tools or?
Okay, so yeah, that was a very difficult thing. It was a very trial and error thing to guess. But again, I said, what's on Thingiverse that could maybe help me with this? And I found this gauge where you can, say for example, if you wanted to make a 3D printed case for your phone, you could say, oh, well, that is 6 millimeters, or this is 12 millimeters. So you can start like prototyping cases or accessories for a tablet phone or your printer or anything that you can think that has a rounded corner.
And that's 3D printed.
And this is 3D printed.
This is crazy.
Within minutes, and you can see the resolution on these.
Yeah, it's gorgeous.
Numbers. You can really see that that's a 3 and that's a 1 and 9, 10, and so forth. It's really fantastic.
Wait, so this is printed?
Yes, this is an experiment that I was doing. So this is what I like about it, is that you learn something about the materials and like design that if you haven't even gone to design school or like manufacturing products and things like that, you can literally learn it yourself. You know, I remember having a computer as a child, and I taught myself to program as a teen, and then, you know, I've made a career of it.
Right.
And it feels that these are those devices that computers were to me in my teens, is that you can actually start figuring out designs and how to put things together. So, say for example, like with that Maker Show logo, I did an inset in this white material, and then I just tapered off the edges of all these letters, and then I just super glued them on. But even just experimenting, making this signage, you know, I was able to think about designing things in the physical world, which I'm not that used to, you know, being a software developer.
Right. You must be coming to one of those places where everything is like, oh, I could print that. I could print that.
Oh, absolutely. Like all the time, I'm thinking, oh, I could probably print that. I can. I don't necessarily have an example, but yeah. I'm always like so surprised at like what is there on Thingiverse. So you can go to Thingiverse and okay, what do you like? What do you like?
Oh, I would like to have probably an example. Do you have something here that you think is really cool in here?
Okay, so you play the guitar, right?
I do play the guitar, yeah.
Let's type in guitar and see what comes up. So what is that? I don't know what that is.
That is a capo, yeah. That helps you put a capo on the thing, and you can just print the
capo. Okay.
Wow. I think I saw an actual guitar.
Yeah, I don't know.
A ukulele, a playable ukulele that you can 3D print.
Yeah, with no supports. So.
Wait, what? With no supports, like no strap?
No, supports are elements that, say for supports are for elements that have to print over clear space like this, if it's at that degree.
Oh,
remember, it's layer upon layer.
Right.
So you actually 3D print supports that will allow you to print over space like that. So
because it would fall over.
Yeah. So you end up actually using more filament than the actual model itself for those instances. So, you know, with your ukulele, you probably have to have supports underneath the bottom of the, what's that called? Handle?
Sure, neck.
Yeah, the neck. Yeah, so you'd need supports under the neck probably, or inside the base.
Base, sure.
Yeah. So you'd need supports in there.
Wow.
So this My Little Pony needed supports on the neck, and around the tail here. So you can see on the inside here, there's maybe a little bit of
Like a leftover.
of
Yeah.
it. So you can 3D, so you can sand these things in order to.
Is it sturdy enough? Like, can your kid play with that?
Good question.
You don't have to go into it if you don't want to.
So yeah, your kid could play with it and it could break.
Okay. But it's just
But just with anything, right? Instead of going out to the store, you can create a new one. But there are like ways to strengthen it. I don't know if you noticed, but it's a bit glossy.
Sure.
I used acetone to finish this, so it actually removes the layers and it smooths the bonds, the chemical bonds between the layers, so it becomes more rigid, so that they can play with it a little bit more rough.
Okay, and that's the point of the acetone.
Yeah, that's the point of the acetone, is to make those layers less pronounced and chemically bond those layers together.
Cool. So what are you doing with this prototyping? Like when you're done?
So prototyping, yeah, when you've finished with these 3D printers, you may want to take that product to market or use it as a gift. There are like third-party services out there that you can give that 3D design to print in all sorts of things, sandstone, acrylic, and even metals. So it's my wedding anniversary next Friday, and so I thought I would start working on a prototype of, this is a copy of my wife's wedding ring, and I got it printed out in acrylic.
That's so cool.
And I thought, oh, let's try it out in a non-precious metal first. And this is a brass ring. So
how'd you get that printed?
So you upload this file that I generated in that 3D modeling software, and they print it for you and send it to your home. So the service is called Shapeways, and it's the primary place you'd go to finish off prototyping like jewelry like this. So I hope she isn't watching, but I'm going to put a message inside and then get it printed in a more precious metal.
Oh, very nice.
An anniversary gift.
Very nice. I've been noticing that these are all kind of small things. Can it only do what can fit in here? Is that the constraints?
Well, in one print, yes, but
whoa.
You can print things pretty big if you attach them all together. So this is a sword from Destiny the game.
Wow.
And this was 2 beds worth of print. So it took about 36 hours to create. And then I went to Home Depot to get a 3mm metal rod to go up there to give it more structural integrity, because it's very light, this plastic. It's not that.
Yeah.
It's not that heavy, and you'd probably want to finish it off like it. I don't think you can see this on the camera, but there were gaps in the side of this. So I used an epoxy to fix it up, and just to fill in those holes. So then you can sand it down, and then you can use acrylic paint or spray paint even. We did at Christmas, we 3D printed a deer, and then we used primer and gold spray paint, and it was a thing that we used on our Christmas display, and my wife liked it. So,
nice.
So these things aren't just like tacky little.
Right. Did you print anything else for the holiday time?
Sure. So here's some cookie cutters that we.
Oh, no way.
We downloaded from the internet. That's kind of strange, isn't it? Just saying, oh, I downloaded cookie cutters from the internet. You can literally do that now.
It's a little reindeer.
I don't know if you've seen those adverts on at the beginning of movies. You want to download a car? And it's like, you can now. You can download a car. Sorry. There you go. And
great. This is cool.
And this is what we put on the top of the tree. It's a familiar.
It's a Super Mario star.
Yeah,
huh?
exactly. So
Nice.
we just shoved a light up there, and it looked brilliant.
It's great.
And when I went to see Force Awakens, I gave all of my friends a Star Wars
Snowflake, a little stormtrooper snowflake. That's awesome.
Yeah, it's pretty cool, isn't it?
That is really cool. And this is all from Thingiverse.
All from Thingiverse. I downloaded. Just think of something and go to Thingiverse. And there's things you can download. It's great.
What's some of the more crazy stuff that they have on there?
Okay, so you can literally print a robot that's the size of a human in its constituent parts, that is. It's called the InMove robot, and there's guides on how to actually create your own one of these things. And it talks to you, it recognizes you, it's got a 3D Kinect scanner, so it can detect its environment and everything like that.
Whoa, so you got the robot's arms and stuff. Are people using this for like health and science?
Yeah, so prosthetics is an area where 3D printing is being used. So getting a prosthetic limb can be hundreds of thousands of dollars,
sure,
and even with insurance. So people are donating their time with the 3D printers. They're downloading models for children who have maybe part of their arm not fully developed, and then they 3D print these little arms like this, where they can actually get functionality back and grip things where they wouldn't be able to before.
That's
so
incredible.
Like drinking, catching, or, well, maybe not catching a ball, but definitely throwing, and things like that. So people are, there's a human element to these things as well that, people are donating time and resources into creating,
awesome,
which is really nice and heartwarming, really.
Yeah, totally. So you can print swords, but what's the biggest thing that you ever heard of being printed?
A building. So a building. Yeah, they were doing it in China, using cement, using that same principle, laying down cement in 3 dimensions.
You can put cement
layer.
on these things?
Not in these ones in particular. The bigger 3D printers built on the same principle.
Okay, so you can put cement in the bigger machines. Are there other things that you can put in here other than those filaments?
Absolutely. There's these filaments that are composites. So they've got the PLA element and then something else. So some people have conductive materials, some people have steel and iron, and much, much more. And in fact, there's a manufacturer of those filaments just over the water in Washington.
Oh, yeah.
So we can go there and see how they do it.
Let's do it.
Let's do it.
We met with Alex at Protoplant HQ in Vancouver, Washington. Protoplant is a local manufacturer of 3D filament that they call Protopasta, that they manufacture and ship from their location in Washington. Protopasta use a gnome as their mascot because of the wonderful magical things people create with their filament. In addition to plastic, they also create 3D filament infused with carbon fiber, steel, iron and conductive materials, all of which you can use on a standard 3D printer as long as you have a special hardened nozzle attached. Protoplant also make a few more surprising types of filament.
We say don't eat the pasta, but we do mess with you a little bit, right? With the coffee filament.
Okay, so how did that come about?
How we arrived at coffee is not we want to have a coffee filament. Mm-hmm. We thought about printers and plastics. It's putting an industrial process in your personal space, mm-hmm, which is a very unique thing. Mm-hmm. But we looked at that and we said, well, why can't this be a pleasant smelling experience? And so then from there we said, hey, what do we like the smell of? And we do drink a lot of coffee. So we were just coffee! Oh. And so that was really our first, once we identified sort of the problem we wanted to solve, or, that was our first scent on the list.
Okay.
And it worked quite well. It gives a beautiful color, a nice scent for the user. We actually did release one other scented filament. We did a special edition last Christmas, mm-hmm, of a pine scented filament.
Oh, whoa, cool.
And that was awesome, but really painful to make because we got the pine needles, we dried them out, we pulverized them, we screened out the big particles. All this is very labor intensive, mm-hmm, and then finally introduced it to the plastic. Mm-hmm. And it turned out really nice. It had this beautiful, actually one of the vases over there is made of that, and it has this beautiful wood fleck. I can't think of another material that looks like that. Mm-hmm. So that was really fascinating. But to do something like that, we'd need to find a little bit more industrialized or way to do that. to keep our sanity.
Kind of reminds me a little bit of like strawberry shortcake dolls, like this. Has it been?
No, it's been great. For every like naysayer that's like, oh, that's kind of dumb, there's tens, hundreds of people that are just like, they just have fun with it,
Okay, you got me sold.
Yeah, it was cool.
Yeah, it's totally cool. I am so sold on this. What do I need to do to get started? Like, how much does this cost?
Okay, so there are kits out available to build your own 3D printers, but these ones actually come fully assembled. This one in particular costs $200.
$200?
$200.
Only $200?
Yeah, that's not bad, is it?
No, it's amazing.
You'd probably be able to build something like that size.
Right, sure.
Those are exact measurements. So $200, you can get this 3D printer and get going. You'll need obviously to buy filament.
How much does that cost?
Okay, so a spool about this size, which is, they come in kilograms generally, is about $20 to $40.
Okay.
I get the ones available on Amazon for about $20.
Okay.
And they've done me well.
So these spools, they're $20, but how many prints do I get from that?
Well, it really depends,
Okay.
because each print is different.
Sure.
Each print is different. So like this one,
The Game Boy one.
yeah, obviously doesn't have anything on the inside.
Right.
Whereas this has a lattice structure inside that to give it strength and sturdiness, which you want if you're slamming things together.
Right.
So depending on the infill, that's what it's called, the infill, depends on how long your roll will last.
Okay, gotcha.
So depending on what you're making, if you're making cookie cutters all the time, then it'll probably last you forever. If you're making massive objects like a globe, it would probably run out very quickly. So it really depends on what you want to build. If
Okay.
you're making enclosures like this, a $20 roll will last you a long time.
Okay.
Whereas like bigger objects like this, this would probably cost maybe a quarter of a spool or half a spool or something like that maybe.
Is there a way to know before you go?
Yeah, there is.
Because I don't want to print something off and be like, oh, that cost me $80.
Yeah, okay. So when you prepare a 3D object
Yeah.
to print, you need to go into a piece of software called a slicer.
Okay.
So once you're happy with the size, you can adjust the sizes here of your model and make it bigger and smaller.
And this thing's specific to your printer?
This can work with many printers, different
Okay.
printers, but the actual code that tells the motors to go left and right and up and down is specific to your printer, but this software can work with many printers.
Okay, gotcha.
So you import your model, you say you want to print it at a certain type of quality or infill, and then when you say prepare to print, it will say, because you've put in your numbers of how much your filament costs per kilo, how much it will cost to print the object.
Nice,
So
it does the math for you.
Yeah, it does the math for you, so you don't need to worry about it. You can just say, actually, let's take the infill back, and
Right.
then it'll print quicker as well because you're not doing so much.
Right.
And also it'll be cheaper.
Cool.
But depending on what you're building, there's certain physical qualities you may need.
Right.
So you may need that infill.
Cool. So you're saying this is $200. In my mind, these things are like $10,000.
Well, yeah, that's right. Like this one here is about $1,000.
Okay.
But yeah, even consumer ones are between like 200, 3,000 range. Prosumer, they call it.
Okay.
The reason why that these are coming on the market now is because many of the patents that were involved with this style of extrusion and printing have expired. So innovation can take this form now,
Right.
because the patents are gone. Patents are bad. So we're getting these 3D printers now. There's other types of 3D printers that use light in resin to create objects, and those patents are starting to expire now, and we're starting to see more of those consumer 3D printers coming on with higher resolutions. But they're not as affordable as these type of 3D printers.
Okay.
And I think that covers it, right?
Yeah,
3D
I've learned
printing.
so much. Thanks so much for taking that, whatever.
Yeah.
Yeah, thanks, man. We didn't talk about that at all. That was, cool. Yeah, totally. I learned so much. Thanks, man.
Yeah, and thanks for joining us. We hope to see you again. If you've got any ideas of topics that you want us to cover on That Maker Show, hit us up on social media. And until next time, we'll see you then.